Okay, IED, Activity 2.2.4, Structural Analysis, Part 2. The first part, we took a uh, video of a coffee maker and we found out whatever, wrote down all the disassembly charts of the parts and all of the information that went along with it. This time, we're actually going to have a chance to do it ourselves. So if you're in class and not digital, we're going to take an object and we're going to take it apart. It's generally a good idea whenever you try to reverse engineer something that you have these particular tools at your disposal just handed out there. So like it's like a reverse engineering toolkit. Screwdriver set, needle nose pliers, hex keys, dial calipers, hand lens, in case you need to look at some parts up close, scale, protractor, ruler or a tape measure, some small plastic bags to keep really tiny parts in, really good idea, and some safety glasses. Whenever you're pulling things apart, a lot of people don't think about safety glasses and they're like, well, why do I even need that? But if you're pulling some snap fit parts loose and that plastic breaks, there's a remote chance. It's not, guaranteed to happen, but there's always that remote chance that some of that plastic could just fly right in your eyeball. So it's always a good idea to have some safety glasses when you're tearing something apart, especially if you're applying a bunch of force to it, because it could not go the way that you want it to go. 99% of the time, everything's just fine. There's always that random remote chance that something might not happen, or something might happen. All right, so in your engineering notebook, once you actually take this apart, if you're digital, I have a video of the carabiner pin being taken apart, as well as a little bit of the measurements along with it. So you can use that video. I'll try to link it using the YouTube stuff and at the end of this video so that you can actually see it and just go straight to it. But we're going to basically have the product, we're going to disassemble it, and after you disassemble it, you're going to create an annotated pictorial sketch or photos as necessary to describe the operation of the product. Keep in mind that says annotated, so you can't just take pictures of it and be like, well, I'm done, because that's not going to be enough to me in order for me to say that you actually reverse engineered or disassembled this product. So identify each component of the product on the sketches or the photos. So you're going to have to come up with a name for these things, and some of them kind of look weird. Carefully observe and measure each part using the appropriate measuring devices. It's really important that you do both of these things because my intention ultimately is for us to reverse engineer this part, which means that you're gonna need the dimensions because we're gonna be making 3D models of them. So if you're just like, oh, I just took it apart and then I put it back together, and then I'm like, well, great. What's the dimensions of this? And you're like, I don't know. I didn't write it down. You're like, well, great. You actually took it apart literally for no reason. So please make sure that you get the measurements because our intention is to three-dimensionally model these products. All right, so um, let's see, I think it says create an annotated isometric sketch of each part with orthographic projections as necessary to detail the part with dimensions. So you're going to be creating a top, front, and side view as much as you can. If you already have sketched the part, add any missing annotations to the previously created sketch. Number 5, to consider the choice of materials for the product, research the materials. Refer to the product disassembly uses of common materials to start your research, then either justify the choice of material or present an alternate material that you believe would be more appropriate for the part. Include the mass, the workability, the durability, strength, transparency, frictional properties, flexibility, and resistance to fatigue in your entries. So there's a lot of different stuff in there. So you might want to actually make sure that you click on the product disassembly uses of common materials to get an idea of what all of these things are. So like if you don't remember what durability is, or if you don't remember what the transparency or the resistance to fatigue is, make sure you click on that so you can actually get some information about it. Record your findings on the product disassembly chart. Identify each part of your product by name, quantity, size, function, material, finish, interaction of parts, and general notes. So you're just going to be making a product disassembly chart just like we had for the other one as well too. I'm going to try to make a spreadsheet version of that available on a Google Doc so that you don't have to have it like on a specific sheet of paper, or maybe just have it as a table. I'll see what I can try to squeeze in there for y'all. Let's see. Compare your hypothesis of the product's operation to its actual operation. So at the very beginning, you should have at least kind of had a guess on what it's going to look like on the inside. So test what your guess was to how it actually performed and what it was in real life. So the more times you break stuff down, the more your hypotheses reach the expectation of reality. Normally, if you first start disassembling something, especially if it's your first time to take something apart, you really don't know what's going on in there. Like you can look at it and be like, I think that this is happening, and then you open it up and find out that you're completely wrong. Some of the stuff that I still disassemble, I look in there and I find myself surprised by what the heck is actually in there and making the thing do the thing. So anyway, the last one that we need to go over after we do all of this, there is a lot of work in this breakdown. So the last one is what structural aspect of the product supports its function, and why are the different parts made of different materials? So those are the two reflection questions that you have to answer. So once you get all of these created, okay, once you disassemble this, you're going to be doing numbers 1 through 8, and then that is what you're going to be turning into me. It may be that you have multiple files that you're going to have to turn in, or what you could do is you could just literally throw it all in on one Google Doc and just turn it in as one assignment, or you could just turn it in multiple clumps if you want to. Either way is fine by me. And if you're not my student and you have a different teacher, check with your teacher and make sure what they actually want you to do and what they all want you to turn in. So have a great day, and I will talk at you guys later.